important for your CET, not few things, everything. But 1 minute, let me share the screen. Yeah. Don't write
Now, obviously, don't
today's
ask me
notes
one
in the
question
same
telling,
book
sir,
as your class book.
few concepts which has been taught in today's class was not taught in the offline class. There's a reason. Depth is not required when it comes to board exam. Remember this, okay? You can predict a lot of things. Here also you can predict, but see, there's one concept which I'll be, so by the end of today's class, I'll be teaching a concept based on cube. Now, this cube concept I still haven't taught you guys in board exam. I won't teach you there because it is not required. Fine. Now that being told, Gauss law, we spoke about that in the other class. So in today's class, we'll be talking about application of Gauss law, but not in terms of derivation. Getting it? So today's class will be more like precise information, whatever is required, out and out only for a competitive exam. I will not be deriving stuff. So for example, one more hint I'll give you. The other day when we, one more aspect in fact, the other day we spoke about something called as equatorial plane and there was a derivation based on it and all those stuff were there, correct? Today's class, I'll only be using the formula of that and trying to get an answer. I won't even think twice. Got it as to how things work. So if I write the answer as 2p by r cube directly, now don't ask me how because the other day we derived it. That is not the derivation is not required in today's class. Fine. So a lot of stuff will be added, a lot of stuff will be removed. This is out and out based on competitive exam. Don't get confused. Okay. So if you can maintain a different book, completely fine. But or if you can write these things on a sheet of paper also is completely fine. Now, along with these parts, we'll obviously be trying to who is these people to revise few stuff. For example, Coulomb's law, application of Coulomb's law, and all was there, but I'll just give a glimpse of it so that once we start solving questions, you shouldn't be in a state to not know it. Now, today's class in Coulomb's law, we will be going to a lot of depth, which was not required for a board exam. So keep that also in mind. So first thing, we'll start off with Coulomb's law because that was the first topic there. Formula was very simple. F equals 1 by 4 pi epsilon naught q1 q2 by r square. I'll pause here. Now see, I'll add few more things here. The first point I'm supposed to understand here is, let's say there are two charges. One is q1, one is q2. Now, in the board exam in the PUC class, we didn't talk about what happens if there are different charges. I'm talking about if it is plus, if it is minus, all those things we didn't talk about. So today's class we'll talk about that. So initially, I'm talking about two positive charges. We obviously know that two positive charges or same charges will always repel. So the repulsion or attraction is also a force between the charges. So how do we calculate force using Coulomb's law? But the other day I simplified this. I just know I just told you wherever the word force is being used and the word charge is being used, 100% they're talking about Coulomb's law. The reason the other day I did not talk about plus or minus is because I spoke to you guys talking about the magnitude of charges. So whatever has been given in the question, either positive or negative, you don't care because it only depends on the magnitude. Fine. But today's class, just imagine there are two positive charges, 100% there'll be some kind of force. The force is calculated using Coulomb's law, and that force will always be repulsive in nature. Now, by chance, what if I take two charges and one is positive but one is negative? Will there be some kind of force? 100% there will be some kind of force. But this time, okay. And that force also will be calculated using the same concept called as Coulomb's law, but it will be an attractive force. Attraction will be there. Getting it? Force by default. Now, let's go. I want you guys to be very active on the. I mean, to you while using the what do you call the chat box here. Fine, because there are a few questions which I will ask, and I expect you guys to answer them. So be alert. Now, for repulsion done, attraction done, how do you find both the answers using Coulomb's law? That also is understood. Now let's get a little more deeper into the same formula. Q1, Q2 we spoke about. R is nothing but the distance between both the charges. Can distance be negative? 100% cannot be negative, which means the denominator positivity. Okay, positive things are there. Now, the left out part is called as 1 by 4 pi epsilon naught. Let's dive a little deeper into this because at this point of time it is required. For the next 5 minutes, please focus. I will introduce one concept which was not there in your NCRT. Okay, I mean, board exam. 1 by 4 pi I will ignore because all of them are constant. One is a constant, 4 is a number, constant, pi's value is 22 by 7. End of the day, both of them are numbers, still a constant. Epsilon naught, this is the meaning I spoke about the other day, telling permittivity. Okay. Now, what does permittivity in this sense mean? I'll talk about one hypothetical situation. Please focus. I'll take 2 points. Point one, there is positive charge. Point two, there is negative charge. Now, what kind of force do we expect to be between them? 100% attraction force, attractive force. Reasons because opposite charges always tend to attract each other. Point number one done. Now, currently there is air between both the charges. Fine. Will there be restrictions from the air? There will be restrictions, but not much. Should it always be air? There are no rules of that. I can put glass. I can put water. I can also put mercury. Fine. So this specific thing, which was okay in 10th standard, we used to call this as medium. Okay. The medium through which whatever passes is what we used to call. Here also there's a medium. Now, if the medium changes, will there be any change in force? Is a CET question. Now, this question will not be asking your PUC. Don't worry. So, if the medium changes, will there be any change in the force? Is the question. Now, the answer is a yes. How will okay? What will be the change, and how is the concept? How will we learn it? So understand, we do not use the word medium in this chapter. Okay, we do not use the word medium in this chapter. We tend to use a word called as dielectric. Dielectric. Now, people who have opted for electronics, they'll be knowing this. Introducing a dielectric medium between two plates is what they tell. I'm not sure if it is in first year or second year, but 100% it will be there. When you guys learn more about the capacitor, you guys will be coming across this concept called as dielectric. Now, I told you, okay, what's the basic meaning of dielectric? Some kind of medium. Okay. Now, can this medium be air? It can be anything. It can be air or vacuum or, mercury, water, anything. In fact, it can also be a metal. So let's say, see, mercury is a metal. Let's say I introduce mica. I can introduce mica also between both these charges, and that also will affect it. Now, understand, in dielectric, representation is caps K. Don't get confused. If I write lowercase k, it means I'm talking about this constant called as 1 by 4 pi epsilon naught. If I write capital K, I'm talking only about the dielectric. And always remember one fact. Whenever there is a dielectric introduced apart from air is an exception because that's a reference. Okay. Anything apart from air has been introduced. So let's say in the next stage, I take 2 points. There is plus Q1, there is minus Q2 here, just like the previous case. But instead of me drawing a line, I'll put a slab here. And this is a slab of some random material, let's say. So since I'm not specifying any material, I'll use the word dielectric. Correct? So I'm telling you, yes, in this is case number 2. In case 2, I am introducing a dielectric between both the charges. Now, first question. Will there be force between them? 100% there'll be some kind of force between them. Okay. How do we calculate force? Using Coulomb's law. This also do we know. Now, what's the difference between case 1 and case 2? In case 1, the dielectric was air. Okay, the dielectric was air. Now, if the dielectric is air, it means that the value of capital K is equal to 1, which means it will not make any change to the force which we calculate. Because see, if I take the answer as 100 and multiply it with the number 1, do you think there's any change in the value there? Absolutely not. So the answer also will remain as 100. So it's an advantage. So wherever the value of K is equal to 1, okay, there will not be any change in the force. Be it attractive force or be it repulsive force, absolutely zero change in force. Now, by chance, if the value of K changes to become, let's say, 4 or 5 or 6, 100% there'll be a change. Now listen, here I'm telling you, let's assume that the value of K here will be equal to 6. K's value will be equal to 6 for a material called as mica. Okay. I introduce a dielectric. Now what do we expect? Force can be found. Will there be force? Yes. The force will always reduce whenever a dielectric is introduced. Remember that. Force will always be reduced whenever the dielectric is introduced. I'll give you many examples. So many are there. Okay. So let's talk about a football game here. Okay. Two sides are there and both of them are trying to score goals. Okay. Let's talk only about one side, which means one half. Okay. So that's the center. This is the football or whatever. Just imagine there's absolutely zero people on the field and only you are there. Okay. One person is there. Now, if I ask you, try to score a goal within no time. See, it will take some time, but within no time, you'll score a goal. Why? Because resistance was absolutely very low. In other language, it was literally zero. Now, what I'm going to tell you is, this time, be on the same football field, but I'll introduce somebody called as a goalkeeper. Now, compared to case number 1, don't you think case number 2 will be little harder? But again, I'm not trying to tell impossible. It depends on a skill, correct? But Compared to case number one, case number two is little difficult. Okay, so the difficulty level increased. What is the meaning of difficulty level increase? It means that the value of R, resistance, kept on increasing. I'll put a smaller arrow mark here. Now I'll bring case number three here. Now I'll tell you, along with the goalkeeper, I'll be placing two more people on the field, and these people will be called as defenders. Now, compared to case 1, case 2, case 3, which one do you think is the hardest at this point of time to score a goal? Obviously, case 3. Now, what happened? Resistance kept on increasing. Okay. Now, I'll be like, along, you are alone. Fine. But to favor you, I'll give you two people on your side. So automatically resistance decreased because I can use these two people and score the goal. Okay, and score the goal. This is how it is. So I try to compensate. But now I'll tell you, totally on your team there are three people. Okay, but on the opposite team I'll introduce 11 people. Okay, so now what happens? Even though you use these two people efficiently, resistance or difficulty level kept on increasing. So in case number 4, R was the highest, which means case number 4 is like introducing a dielectric where the value of K is equal to 6. If I introduce a dielectric, and guys, I forgot to tell you one more thing. In all the 4 cases, you still have a chance to score a goal. I am not trying to tell it's 0%. You still have a very nice chance. Depends on your skill, depends on your teammates, depends on how good the others are. I'm talking about the other team. Okay. So there is all the 4 cases, there is not even one instance where the chance of you scoring was 0%. Every time you'll minimum have a minimum chance of 10% is there. Okay, maximum is 100%, obviously. So there is always a chance. Similarly here, there is always a force. Now, how strong is the force? That depends on the dielectric. If there is a dielectric, the force will always reduce. So what? So how do we write this? We write it as F dash, the new force. What's the meaning of new force? After the introduction of the dielectric, the original force always reduces. Now, understand, I'm using the word reduces here, okay? In order to reduce a number, there are only two ways, only two ways. You'll have to either subtract or you'll have to divide. Fine. Now here, what works best? Subtraction does not work. It is always division. So I'll write K. So the new force will always be equal to the original force divided by the value of K. I'm talking about capital K, where the value of K is always the dielectric. Now, will the value of K be given to us? Yes. So let's say F dash is equal to F pi. If I tell the dielectric is air, just now I told you the value of K is equal to 1, which means the answer is 1. F dash will be equal to F by 1. So didn't I tell you? Even the dielectric is air, there's absolutely no difference in the new force and the original force. It won't show. But let's say I take the answer as mica. The value of K for mica is 6. So F dash will become F by 6. So if you divide something by 6, automatically things will reduce. I'm talking about attraction or repulsion. So in this case, it was attraction because both of them are opposite forces. If by chance I take both of them as the same force, they will be repulsion, correct? They will be repulsion, but that repulsion also will be on a weaker side. Why? Dielectric was there. By chance, if the dielectric was air, it will be the same. Why? Because the value of K is equal to 1 for air. This is how things work. So in your books, write down, introducing dielectric will always reduce the original force. This is how we represent it in terms of formula. Now, if you guys forget the concept, remember a football field example. Even though I gave you I can go on and I can give you 100 cases, but combine all the 100 cases, the chances of you guys scoring a goal is still there. It is never 0%. Minimum percentage will always be there. I mean, I'm talking about little skilled player. Okay. Now, if you're playing football using your hand, 100% the answer will be 0% only. I'm talking about a player who at least has some idea about football. Getting it? So you introduce, okay. Now, what are the 4 mainly used dielectrics which is there in the syllabus? Only 4 will be asked. 1 minute. You will make a note of it a little later. One is air, also referred as vacuum. Okay, vacuum. VACCUM. Okay, both of them are same. What to write? I'll tell you. 1 minute, wait. Air or vacuum? In fact, I thought of writing it on my iPad and directly sending the notes to you guys. The iPad is out of charge right now; it's dead. So do one thing. Only for today's class, you guys copy down. From the next CT class onwards, I'll use my iPad, which means after the class, I'll be able to save it on my. I'll save it and I'll send it to you directly on the group as a document. It'll be much more easier for you guys. Okay, but only for today's class, I'll tell you what not to write little later. Air or vacuum, and they use a concept called as other media. Okay, don't get confused with respect to it. I'll tell you what I mean. Or they use a conductor, or they use a mica. These four are extensively used. Now, wherever if the answer is, guys, careful with caps K, it has to be capital K because lowercase k means that constant. Okay, remember that. Do not forget. 1 minute. So value of k will be equal to 1 for air or vacuum. Here, any other media, it will always be greater than 0. Okay, see, I can't tell specifically because they're telling they're using the word other media. That's why. Okay, if it's a conductor, always remember for a conductor, dielectric is infinite. So what happens if I use a conductor? F dash becomes F by infinity. If infinity is there in the denominator, which means 1 by infinity, what's the answer? It is 0. This is not at all true when it comes to physics, but 11th and 12th standard physics, let's stick on to it. Now, if you're trying to do something with if you're trying to choose physics as a career, then you will realize this is wrong. But still, uh, currently, remember 1 by infinity is equal to 0. Now, how do we know this? Because 1 by 0 is equal to infinity. We do one basic nonsense math we do right now. Crisscross we do know. So 1 by infinity will always be equal to 0 is what they tell. I still don't believe in this. Okay. This is what I believe in. Not this one. But can't help. My beliefs won't help anybody here. Anyways, I'll take it off. Okay, conductor dielectric is 0, is infinite. Now, how will this be asked? Will this be asked in terms of numerical? No. This itself is a CET question. So they'll give you four options. If by chance the conductor is introduced between the dielectric, okay, what will be the value of the dielectric? K equals 1, K equals 0, K equals infinite, K equals whatever. So you'll tick for K equals infinity and then come. Okay, so this itself is a question. Now, this can't be a question because that's very obvious. Now, don't tell me, sir, I didn't know about it till now, but fine. It's very obvious. For mica, it is 6. Now, the reason mica has been extensively used is because every other question in CET, mica, they keep telling. So, let's say initially the original force was 60 Newton. After using Coulomb's law, you got an answer as 60 Newton. Now, they'll tell in sub question 2, we will introduce a dielectric mica and what is the new force is what they'll ask you. This can be asked in terms of CET. Now, don't get confused. So, you'll write F dash is equal to original force divided by K. Mica, the value of K was equal to 6. Original force, the value of F was 60 Newton, gets cancelled. The new force becomes 10 Newton. So, you'll tick the answer for 10 Newton and come off. Getting it? So this table is important for you guys to remember. But I personally feel the second is the most important thing because anything apart from air or vacuum. So let's say if I use the word mercury, you should be in a state to at least understand that the value of mercury or the value of K for mercury is more than 0. People will have zero idea. They'll be like, what is mercury? What is mercury doing here? Can mercury be placed? Yes, anything can be placed. That's why I use the word other media. But 100% the answer will be more than 6. See, the exact answer is 13.2, okay, but not required. My gut feeling says nothing will be asked more than 6 because my gut feeling is only based on facts till now, and not even once it has been asked more than 6. Maximum is 6, and usually mica only will be repeated. Getting it? So to summarize this, wherever you introduce a dielectric, 100% there will be a difference in force. Now what will happen? It will always decrease. Given by what formula? F dash equals F by K. What's the value of K? Dielectric. Okay, dielectric constant it's called as. Now the next chapter which we will be doing, it is called as electric potential and capacitance. Okay, any capacitor, it will see the full form of a capacitor is, okay, not the full form, the full name of a capacitor is, it's called as parallel plate capacitor. We only for our purpose, we just use the word capacitor, but the actual thing is parallel plate capacitor. It's called as PPC. So there'll be two plates which are parallel to each other, and there'll be charges lying on each plate. Okay, guys, 1 minute. Listen up. I'll tell you one more concept here. Now, I used to always think if on the left plate, if there are 5 positive charges, by default, the inner side of the right plate, there'll be the same amount of negative charges. Now, don't count it. I've made one mistake. I put off an extra here. But 1 minute, wait, let me clear that. So it'll be the equal amount. Now, how is this happening? I used to always wonder. This happens based on a concept called as induction. Okay, this is how nature also works. Okay, anytime induction only works in nature, which means any positive charge will want to get attracted to the opposite gender called as negative charge. Okay, which means let's say I talk about two plates. There'll be negative outside, there'll be positive inside. Just imagine that. Now, this positive, which is there on the inner plate, wants to get attracted always. Now, because it wants to get attracted, it'll start inducing. It'll start, okay, seducing is the wrong word, but inducing is the actually right word. Okay, I don't know what is the other synonym for it. It'll start inducing. It'll start training the other plate and convincing it, telling, Whatever happens, make sure that the negative only is inside. So it becomes 1, 2, 3, 4, 5. Now the positive will obviously be outside. Now you'll obviously wonder, will the outside charges also attract? We don't care about it. My only thing is parallel plate capacitor, meaning whatever is happening between the parallel plates. I'm using the word between, not outside. So this is what happens here. So automatically there'll be some kind of attraction. That attraction is also called electric field, and all those things will be happening there. Electric field is being placed there. Now what happens? I'll be like, electric field is obviously there. Loyalty. Yeah. Electric field is obviously there. Now, this is me doing it, not the. This is the owner doing it. I'll introduce one dielectric here. Now dielectric, I'll put one mark like this. Now what happens? The electric field between them can either increase or decrease. Correct? No. Now don't get confused. I'm using the word electric field here, not force. But by chance, if I use the force, if I use the word force, 100% it will decrease. Now what happens when it is electric field? I won't talk about that in today's class because that's not in the current chapter. Okay. Electric field, there also dielectric can be introduced. We are not talking about that in today's class. But today's class, we're already talking about something called as force, which can be got, which the answer which can be found using Coulomb's law. If force is there between two charges and dielectric is introduced, 100% there'll be a decrease in it. Okay, that's the concept. That is concept number one. Next thing, dielectric done. One famous question was asked in CET till date. I think that was my favorite type of question in this chapter. Now they asked, okay, after introducing a dielectric, the force reduced. Perfect. Now, how do we compensate this? How do we even after introducing the dielectric, how do we keep the force the same? It's a superb question. So now what you do, just imagine here, Q is there, Q is there, 1 is there, 2 is there. The distance between them is R. Fine. See, dielectric was brought into picture, the force reduced off. Okay, I'll ignore this right now. The only way to compensate it by, let's talk about common sense. F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. I'm trying to compensate, guys. Understand. Ignore this because it's a constant. Do, do we have the power to increase the value of these charges? 100% no. I can't do it. I can't tell you are 10 right now, become 20. Does it make sense? See, best example is, let's say you're 6 feet tall. I am telling, no, I don't like 6 feet tall, become 6'3" within the next 3 weeks. Is it possible? 100% no. Let's say, same concept, 6 feet you're tall, but I don't like you being 6 feet, become 5.7. Is this possible? Not possible, which means changing the value of the charges, that specific power is not there in my hand. But the placement of those charges, is there. So what do I mean is, let's say you're a 6 feet tall dude. I might not make you stand initially in a line, but I will tell you, since you're 6 feet tall, go behind and stand. You always have a place in the line. It is just that you do not belong to place one. You belong to maybe somewhere in the end. Ascending order, no, height order, whatever it's called as. Fine. But I am not denying the fact that I am not I'm not rejecting him. I'm telling you belong to the same line, but you belong little behind. Please go stand there. So this is how I mean. Now what's gonna happen is, I can't take off the charges. So now what I'll tell, both the charges, whatever the value is, I'm fine with it. Let's say it is 10 and 5. I'm fine with it. But I'll just convince both the charges to come closer. So this will become 5, 10 and 5. The charge is the same, Q1, Q2. Now why am I asking them to do this? If the distance between them reduces, automatically force increases. Why? Inversely proportional. So this is the way, even after introducing a dielectric, the only way to compensate the force, I repeat that. The only way to compensate force, even after introducing dielectric, is by reducing the distance between them, not by changing the value of charges. Okay, very important concept. So step one is the original force. Step two, you bring K into picture. Now, will there be any change? Yes, F dash becomes F by K. There's a loss here. Now, how to compensate the loss? I can't change the charges, but I can convince them to move together, or to not together, sorry, to move closer. Why? When you move closer, the distance between them decreases. When the distance decreases, according to Coulomb's law, force will increase because both of them are inversely proportional to each other. Any doubt till now? No. So this, understand. So I gave you multiple concepts. All these things is absolutely 0% important for your board exam. I am only telling you. Okay, guys. In fact, I'll tell you. Listen. One more derivation which was cancelled last year has been again introduced this year to you guys. So I thought last class only the chapter was done, but not yet because they've introduced this thing. So next class, I think the first half will be doing one derivation. Okay. After the derivation, I'll send you. I'll when I meet you on Monday, I'm talking about. I'll send you a PDF. This PDF, save it onto your computer, laptop, whatever. That will deal with all the previous year's questions as well as the most important board exam questions on this chapter, which also includes numericals. I will give you one PDF. I'm still writing it. I thought I'll write chapter by chapter. Fine. I'll write it by Monday and give it to you. But by chance you open that PDF for CET, no, 100% wrong it is. Getting it? Now, in that PDF, you will never see the word dielectric being used. You will never see the word how to compensate the loss being used. Nothing will be there. You want to expect that they'll be like derive axial point, derive equatorial point, derive that, derive this, derive that only, and numericals. Those kind of questions will be expected in CET. These compensating dielectric, I mean, I interchange and told off, but the compensating dielectric, all these original content belongs only to CET. Got it? So I hope this I made clear. Dielectric reduces forces. How do we compensate it? By bringing them closer to each other. This should be imprinted in your mind. Okay, CET very important. This is. I think this is the only question where people have to use brains. Apart from that, everything else is okay. There's one more concept we're supposed to use brains. Anyways, I'll go to the next concept. Uniform external field. We spoke about the other day. Okay, tau. I told you PE sine theta. This we derived. I also told tau will be equal to P cross E. This is where we stopped in the previous class, I feel. Uniform electric field. One superb question was asked. I forgot the year in CET, but they asked, what if the charges is placed in non-uniform electric field? What will happen? Now, first, let's try to understand the difference between uniform. Guys, I am done with force. Don't get confused. I'm talking about electric field. Electric field is given by the formula F by Q. Okay, I'm talking about electric field, where the formula is 1 by 4 pi epsilon naught into Q by R square. Only Q will be there. No, no more force. Done. I'm talking about field. So let's say, and remember, we also spoke about something called as dipole. That I'm talking about. Uniform electric field meaning between, okay, these are called as electric field lines. Between each and every field line, the distance is parallel, which means if it is one here, it'll be one here, it'll be one here. Only then you can call something to be uniform. But by chance, let's say the distance was like this. Okay, this will be called as non-uniform. Now, the whole concept of non-uniform is there will be one place where the electric field is really strong, the other place it will be weak. Now, see here, don't you think they are trying to get crowded here? Wherever there's a crowd, it means that the field is stronger. Okay, wherever there's a crowd, it means that the field is stronger. Here, don't you think there's so much of distance? The field is weaker here. The field is weaker here, which means you expect more amount of field or more amount of what do you call experience to happen here compared to the outside world. But here you place the field, you place the charge anywhere. You place it here, you place it here, you place it here. Everywhere it's the same. It's the same. It absolutely will not change even 1% of the outcome. Here, every small movement will change huge things. Fine. So I hope you guys understood. Wherever things are closer, wherever electric fields are going together, that means that the place is stronger there. I will not place. Sorry, electric field is stronger there. Outside it is weaker. Now, why are we supposed to learn this and all these things? I'll tell you. But I hope you guys understood it. Fine. Now, uniform electric field, we spoke about it. Non-uniform also, we spoke about it. Okay. One addition I'll do here. The other day when we spoke about uniform electric field, that is when torque came into picture. What's the meaning of torque? Rotation will happen like this. Correct? Rotation will happen in the same place. Now, what's the best example? Just imagine a wheel. Okay? A wheel is stuck to a wall. Okay? It's a wall. I've nailed the wheel there. And the wheel keeps on rotating. The rotation force is called as torque. But is the wheel moving forward or behind? No. It is stuck in one place. Where will this happen? It will happen in uniform electric field. Okay. It keeps on spinning like a top. Now top sometimes it moves here and there, but I'm just imagine a top is being glued to one specific place. If I put a dot and tell the top should spin only here, it is only spinning there. Okay. Now if I take the same dipole, okay, and if I place it in a non-uniform electric field, what happens? There will still be torque. It will be moving, but once It no, just imagine the wheel. Just imagine same wheel example. The wheel is here, but here it is not nailed to a wall. It is nailed to a car, which means car. Whenever the wheel rotates, the car also keeps moving. So there is rotation happening like this. There is rotation happening like this, but also it is moving. Can you see the movement from left to right here? It never stopped. It started here rotating. Rotation happens, moves, keeps on moving in one specific direction. This is when it is non-uniform. If it is uniform, yes, there is rotation, but in the same place. If you see, there's one place. It is right there. It is spinning, but one place. This is uniform. Okay. CET question. Non-uniform, what happens? Uniform, what happens? Both the places there is rotating. Torque. Both the places is there. But here, torque is fixed. Here, torque keeps moving. And there's some kind of moving in a specific direction. It moves and it covers some kind of distance here. Very important. Where does it move? Non-uniform. Where doesn't it move? Uniform. Now, what moves? The dipole. The dipole. Okay, plus q minus q. The dipole keeps rotating, same place, uniform, different place, moves non-uniform. Understood as how things work? Important. And now this why wasn't this been taught? Because non-uniform is not there in the board exam syllabus. Syllabus only it's not there. It's there only in CET syllabus. That's why it was not been taught in the other class. But this I had to teach because if I just tell what happens in an electric field, you can't tell torque. Torque is correct. It rotates. That rotating force only is called as torque. You should stick on the word rotates. Then only think about how it rotates. Now you realize in uniform it is rotating. Now if I ask you what happens in the non-uniform, you will tell yes, it is also rotating, but also moves in a specific direction. Movement has been present. Any doubt till now? Oh, very nice. Sometimes no, I'm very proud of my explanation. I feel no doubts you guys will have. Okay, now we will have doubts. See, Gaussian surface. Okay, Gaussian surface. See, the other day I thought of an example, okay, but I didn't want to use that example there because I was saving it for here. Gaussian surface, best concept, I'll tell you. The other day we spoke about some random incense sticks. I told you if there's a long, infinite long wire, you'll have to use a cylinder. All these things I told you, correct? Ignore all these things because this is more of board exam question. I don't like learning that way. Let's stick on to how do we learn it in a very what's the right word? How do we learn it in a very CET way? Okay. So, one second. Okay. Correct. Now, just imagine everybody sitting here has eaten dosa. Okay. I'm wondering, see, this is my life experience and it might not be true. Okay. Completely true. Wherever I've eaten dosa, okay, they use pans. Common sense. Now, don't tell me, sir, what a thing you do. Just imagine whatever I've come across till now. I only come across three shapes of pans. I'll tell you. If you come to my area, okay, there's this food street concept. I don't stay in Vipuram, but my area now you get little egg and all you get. And little non-veg has been you get here. Now that guy is street food basically. That guy minimum tries to make around 10 to 15 dosas at the same time. He puts eggs and all on it. See, I'll tell you where all physics has been applied. So that guy's pan is like a rectangle. So you keep adding one, two, three, four. I am not a chef basically. So you will adjust and add it. So depending on the number of dosas, you adjust. Now this big rectangular pan won't be in anybody's house because you are not making, even if you're making 10 dosas, you're not making 10 dosas at the same time. And moreover, space. Kitchen only, I see on the kitchen it will be kitchen though will be filled with stuff. On top of that, if you're trying to bring a stove which is like half the kitchen size and it's annoying and moreover heat. Too much of heat will be in the kitchen, which is not at all good. Now keep this in mind. So what I see is at homes they use pans. They either use a square pan or rectangle. Either use a square pan or use a circle pan. Fine. Now I used to always wonder why is that only these three shapes are being used. Why can't they use a pan which is like a semicircle? You think and tell me. See, for example, I'm being very honest. I've never seen a pan where where it is in the shape of semicircle. Now, can't they make like that? They can make because they are skilled enough. If a person is able to make some random square kind of pan and all, he or she can't they make what do you call semicircle? Now, obviously, there'll be one more thing. For this, the pan depends actually on the dosa shape. Okay, I've till now. I don't think so. I've eaten a dosa which is triangle in shape. Now, don't tell, sir. I've eaten masala dosa which was in cone. A cone is a 3D figure. It's a 3D figure. So when they put the batter, okay, the batter is spread in a circular way only. Or maximum, okay, this food street guy sometimes he puts off in one rectangular way and he calls it some random dosa, he calls it. And 115 people are required to eat that dosa. It's very famous, you see. One huge dosa will be there, and I don't know why this. Oh, you can't even eat that, bro. Okay, so I've whatever dosas I've eaten, majority 99% of them are circular in shape. I used to always wonder why should always dosa be circular in shape? Why can't it be, semicircle in shape, or let's say square in shape? I've seen people. Okay, okay. Best example, you go ask your mom later if she's making dosa somewhere. Ask her to put square dosa and give you. She might either take the same thing and hit you, or will give the same batter to you and ask you to make your own dosa. Two things will happen. Now, why only circle was chosen? Because of a concept called as Gaussian surface. Okay, because circular spreading the batter in circularly is much more simple and it is much more even. Okay, just like the charge distribution, charges will get evenly distributed, just like the batter. Now, if you don't know how to put a dosa, and all, I mean, how to make a dosa, just don't try all this shit basically because you'll get confused. It has to be even, or else it will become, what I mean. Some because one place won't be properly cooked, and that and all will keep happening there. So, in order to maintain that thing, it has to be in a certain way. Fine. Now, understand, evenly you spread the dosa and things are being done. Just like the even spread, the charge also has to get evenly spread. Evenly spread on what? On a surface. Now, I've never seen people putting, let's say it's a circular, it's a pan, which is circular in nature. If you can you put a batter here? Does it make any sense? No. Why? It batter is there. It'll get wasted. Will a dosa be made? No. Even though evenly spread it, there's no heat source only. It can't be made. So you require a surface. This surface which covers the entire dosa batter and still gives it a shape is called as Gaussian surface. Okay. Now, three types of Gaussian surfaces are used in dosa making. If it is bulk dosa making, we use rectangle. If or else at homes, see now what people do. Okay. In fact, I've heard people telling we have a separate pan for chapatis. We have a separate pan for dosa. And I think every auntie at home is very proud of the dosa work they made, and they tell that is because the pan was really good. They actually appreciate the pan. You guys can go talk to them. They appreciate the pan really well. And by any chance, if the dosa is not proper, also they go all in on the pan, telling okay, it's a useless pan and shit like that. Okay, and they also make sure that if there's a dosa pan, they don't mix with anything else. For example, you can't put you can't fry egg on it. They're very 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 specific, telling okay, dosa pan is set right now. Let's stick on to it. Getting it? So that Gaussian surface keeps changing from house to house. But nothing apart from these three shapes I have seen. Okay. So Gaussian surface is the one which covers all the charges, and yet the outcome has to be even. That's important. Now, why did I tell this example? We can talk about a cube, we can talk about whatever. Cube is extensively asked in your exams. Now, how will they ask the cube? I'll tell you. I want you guys to understand here. This will 100% go over the head if you don't focus. So let's say I draw a cube. I am telling you the cube is a Gaussian surface. So only for your understanding, I will name it. This end is A, B, uh, C, and D. Okay, it is E here, F here, G here, and H here. So 8 corners done. I have a small question. Corners are 8 in number. Okay. How many faces? Can we all agree that it's 6 faces? That's why it's a cube. Now, I'll name the faces. Let's go step by step. Um, I'll shade it also. Whatever I shaded is the first face. AEBF. AEBF is the first surface. Right opposite to it is this DCHG. DCHG is the second surface. ABCD is third. EFGH is fourth. Okay, where else? Behind. AEDH. Can you see this? AEDH, the behind one. AEDH, fifth. Front one. BFCG. So totally 6 faces. Now, why is it important? Very important. This is. Please focus. Now, let's say, and I hope you guys understand the dosa you will be will can be made only if you pour the batter on the pan. Scheme. Oh, guys, that bloody line is not coming. Okay. Anyways. Okay. Now, six faces, eight corners. I need not name the corners, no, all the letters A, B, C, D, E, F, G, H. Okay. Now understand. I am telling you, let's place a charge. Where will you place a charge? Exactly in the middle of the box. The box is 3D in nature. I am placing Q. Fine. Now, Gauss law was given by phi equals 1 by epsilon naught times the Q, the charge covered. Now, I'll tell you what is the meaning of charge covered, okay? Dosa example I'll give. One circular pan you took, you put one dosa on top of it. So, the dosa, one pan covered one complete dosa. When? Now listen. What if, what if I take a similar cube, but I will change the placement of the charge. I will not place it inside it. I will place it on one corner. Okay, let's say it is whatever. Okay, guys, don't get confused. I'll mark it here only. Both of them are two different things. Instead of placing the charge inside, I will place it. Okay, I hope you guys understood. No charge inside you place, so therefore it is being covered completely. It done. Now think from only E's perspective. Why I chose that corner E? Now the corner E is directly attached to three things. How many? Three. A, H, and F. One minute. Let me use a different color. It is directly attached to A, F, and H. Now why was this important? Now see, how do we? Okay, they'll ask you write the Gauss law for Q if it is placed at a corner called as E. Now how do you start off with this? You will write phi. You will write 1 by epsilon naught times. Now think for a second, okay? It is at a corner, which means the full charge was not being used. Now what do I mean by that statement? Now listen. What if, okay, think and answer this question. The dosa pan I choose is square. On the square, I am trying to get a circular dosa. Okay, so this is the dosa. This is the pan. Now, by mistake, what happens is, on the pan, I only pour so much of batter. I want a dosa only, but I've poured the remaining half like this. So, give me the end result. End result here is half dosa or one full dosa. Half, which means this part got wasted. And do you think the pan cares? The pan does not care. Which means you poured half the dosa on the pan. That half dosa is your output. Similarly, if I just throw quarter of the batter, the remaining I wasted. So don't you think my output also will be only quarter, 1/4 of the dosa, correct? So it depends. So here, if I'm placing the Q at the corner, not the full charge is being used. Only a part of it is being used. Now, what is the part? Is it half? Is it full? Is it 1/3, 1/4? The answer is very simple. How many corners were there totally? 8 corners. Out of 8 corners, how many corners were filled? Only one corner. So therefore, the answer is 1 by epsilon naught times Q by 8. Q by 8. Understood? Why only 8? Where was the Q placed? 8 corners. I mean, one corner. How many corners? 8 corners. Therefore, it's like this. Understood? Now, by chance, I place the charge on one face or one surface. Okay. Now, imagine this to be 3D. Okay. How do I explain this to you? Let's say it's a wall. Wall is obviously 3D. Got it? Now, let's say in the same wall you made a hole for putting some random decorative item or whatever. Okay. What's the best example that I can give you? I can't think about anything, but if you place on the corner, it's always 8. There is not always 8. It depends on the shape. So let's say I take a square. Okay. Now square has how many corners? Tell. This is Q. So when the shape changed, the square has only 4 corners. So here it will be 1 by epsilon naught times Q by 4. Why 4? Because the shape, whatever the charge was placed on, it had 4 corners. Therefore, Q by 4. Okay. So let's say I take a triangle. Triangle has how many corners? 3 corners. So here it will be q by 3. So the 3 or the 4 or the 8 does not depend on the charge. It depends on the shape. So again, those are batteries still the same, no? But it depends on the shape of the pan, whatever you're trying to spread the batter on. That's how it is. So it's not always 1 by 8.
So you
Getting it,
can
guys?
tell me,
So let's say I am trying to place the charge on one of the faces. So what will the answer be? Q 5 will be equal to 1 by epsilon naught times Q, I'll write. Totally how many charges? 6. Arey, Dheeraj, 1 minute, ra. I disconnect my headphone. Share. No talk. Understood. No, I couldn't hear you. Yes. But now tell this. I'm placing it on one of the face. Face is also called a surface. So I am telling you I'll be placing the charge on A, B, C, D. Huh? Guys, nothing. Hey, 4 henge. Hey, mental. It is not placed on the corner. It belongs to the wall. I'll give an example. Wait. Just imagine there's a wall here. Okay. I'll write your name, whatever. Now, is your name covering 100% of the wall or only a percentage of it? Let's say it is 10%. Huh? Correct. So, will you buy paint for the full wall or only for the 10% of the wall? Exactly. Correct. Which means when you're placing it on the surface here, the charge belongs to one surface. Correct. But totally how many other surfaces? So the answer is q by 6. So which means your name, just like your name belong to 10% of the wall, this charge belongs to 1/6 of the cube. That's how it is. You guys got the thing as how it works? So this is nothing but Gauss law. I hope you guys understood it. Okay, now will the questions be this hard? No, but it's an interesting concept. Now this I can't teach in board exam because it's not required. They won't ask you this question. Fine, you got to understand this. So for corner it changes, for face it changes. Okay, if you're placing the first one, if you ask myself why is the first one only Q? Because I took the full charge and placed it inside Q. Just imagine I take one apple, I place one apple in a box. Now, if I ask you, can I place one apple in a box? The answer is a yes. Okay. Apple does not need any of its what do you call colleagues and all the stuff. You place one apple, apple is still happy. Same way. So one full apple was placed in one full box. Therefore, the thing was 1 by epsilon naught times Q. But if I take the same apple and place it on the corner, it belongs to corners, which means it's a different league there. It becomes Q by 8. Face also, 6 face, so therefore it becomes Q by 6. You got to think and then only answer. Okay. Okay, let me predict one thing. This year, one question will come from this. Okay. I won't tell only from these three things, but on a cube. Now, why only cube I took? Why not square? Because usually it is a cube or a cuboid being asked. Now, there's absolutely no difference between a cube or a cuboid when it comes to electric field. Why? Because, see, this is a cuboid I'm trying to draw. Except for the change in length, everything else is the same. 1, 2, 3, 4, 5, 6, 7, 8. 8 corners, 6 faces. Everything is the same. Just like the same. So either cube or cuboid, the answer is the same. But see, for example, square and rectangle also. What's the change? The length is the change. But corners 4, number of sides 4. There's no difference, same way. So when I mean cube, it also by default means cuboid, but it does not mean square. Square, the things will change, as I told you here. Okay, and no mugging up q by 4, q by 5. See the shape. See the shape. Now circle, if I give, you can't tell this only. Why? Circle has no corners at all. So you got to think and only then try to come up with some random answer. And the random answer also should make a lot of sense to a lot of people. A lot of people in the sense it should to the teacher basically. And now obviously ask me, sir, why did you use this yellow and draw these three things? Let's go to the corner again. Okay. They'll ask you when Q was placed on, guys, this will confuse a little. Please focus. When you place the Q at the corner, it is directly being affected by 1, 2, and 3. Okay. Now, out of 1, 2, 3 surfaces, there were other things also, which means if I ask you what happened here, there's something would have happened there. Fine. So always understand, wherever, the electric field is in contact with the charge. Electric field here is in contact directly with the charge. All those places, field will be zero. Fine. Wherever the Q touches, here, that surfaces, the answer will be zero. Now see, Q here is not at all touching the surface here, front surface. Here, answer will be something. Now, what's that something you're supposed to calculate? Which means you can find an answer here. Wherever the Q is touching, answer can't be found there. See, for example, I'll take one more thing here. I'll draw. Okay. Now let's talk about one face. This face I kept. Huh? This face is touching this complete square here, which means the answer will be zero for this face. In the remaining 5 faces, why 5? Because totally 6 out of 6 I used up 1 to place a charge. Remaining are 5. In the remaining 5, you will get some answer for the field. Only on that there will be no field. Remember it. Whichever place, it's like telling this. Okay. Let's imagine you take a room. In that room, you are placing a bulb at one corner like this. Where do you think the bulb's brightness is the brightest? Opposite to it, no? Correct? Now on the same wall, will the brightness be highest? No. There is brightness, but not so much brightness. I'm talking about maximum brightness. Maximum brightness is always on the opposite. But here also there's little light here and there all is there, which means wherever there is light, those walls will get the least light, will get the least energy. Least meaning zero. Where will be the maximum? Opposite will be the maximum. So if you want light on this wall, you won't place the bulb or the source of it on that same wall. You will place it opposite to it. Same way. So let's say I want a light on this wall. You won't place the bulb here. No, you will place it here. Okay, you'll place it here. Opposite, it'll be maximum. Why? Because when you place the bulb there itself, the amount of light spread to the wall is very low, minimal, meaning zero. So let's say you wanted light to this wall. You place it opposite. So therefore, you see, in one house, there won't be one bulb or one tube light. There'll be multiple tube lights to hit different parts of the house. So this wall, there'll be one tube light here. This wall, there'll be one tube light here. So therefore, once you switch on all the lights, the room itself is completely lit. But if you switch off 3 of them out of 4, you will see only a part of it is being lit. So all these things are important. Fine. So this lit only is called as electric field. No, influence. Influence of the light was strong only in the opposite direction. At the same place, it was not that strong. That's the meaning of it. Okay. Same place here. Okay, where is it? Yeah. Here, if I place the charge on this face, it won't show so much of brightness there. It will show in the opposite places. Opposite meaning the remaining 5. Same here. Here, this corner was in contact with 3 other corners. So those 3 corners, the answer won't, the light or whatever, the influence won't be so strong. Opposite to it, the remaining ones will be stronger. This is Gauss law. Now, this depth was not gone in PUC. I'm telling you that. I accept that. Not required there. Any doubt now? No. Fine. Do one thing. Don't make a note of anything. If you made some notes, cool, good enough. We'll have to solve questions also. But in the PDF the other day, so I think I've sent the previous version of it. Electrostatic is not there. So do one thing. Today, read some first year chapter, okay, for KSET, and we'll do questions in the next class. Your choice. Okay. Got any doubt in today's class right now when it comes to CET? No? Yeah.
So
what if we keep it on the surface? In the surface agalla. What is in the surface?
So like on the surface.
There are totally how many surfaces? 6 surfaces, correct? Yeah. Out of 6, you are using up 1. I just now told this example, mental. You are using 1, which means one surface is in contact with the charge.
Yeah.
The remaining 5 are not there, correct?
Yeah.
So the remaining 5 will get equal light or light.
Oh, okay.
Getting it? So that corner was in, see, 1, 2, 3, it's playing a major role there. So apart from these 3 setup, everything else will get.
It's basically placing a bulb in the center of the room.
Not center. Center is also correct, but I'm telling, let's say you place it on the ceiling, okay? I am telling you place it on the center of the ceiling. My argument right now is the ceiling won't get light. The ground only will get light, or the room will get light. Understood? Now, for example, where is the fan placed? Ceiling.
Yeah.
Why tell? Because we want the air on the ground like this. Or do we want air in the ceiling? No. So, ceiling, will there be air? There will be air. But will it be as strong as the one which is there on the ground? No. because the air moves like this when in the fan concept. ಅರ್ಥ ಆಯ್ತಾ?
Yeah, but then so what? So in this concept, even on the top there's light.
There is light.
Okay.
But I'm talking about maximum. Okay. So is that light enough? The answer is yes. But will it give you maximum results? No. It will give maximum results only in the opposite direction. Got it? Yeah. That's it, guys. I think we're done with 80% of the CET in this chapter. I mean, don't tell sir, we still haven't solved questions. Questions on all you guys will solve off if you know this, okay? But this is the learning part of it. So this is exactly how we work. After every chapter, see, almost at the end of the chapter we are in, when it comes to board exams also. So we do CET and based on that only, we'll have to solve questions. But as to how things work, that's how I work here. Keep that in mind. And something else I wanted to tell. Yeah, that notes. I'm talking about the board exam previous year questions. I will give it to you guys on Monday. Fine. So will that be enough for your college exam? 100% yes. If you read, or shit. Okay, anyways, guys. Recently deleted. Anyways, fine. I thought I did it. I think I long pressed on one thing and the notes went off. Anyways, I'll restore it. No worries. So this class we didn't solve questions because I want to talk about theory. Next class, I think first 10 minutes theory I'll talk about. Only small part is left. Okay. Few more, just like the way I took cube, there are a few more other concepts. I think I'll take 10 to 15 minutes of that, and then we'll start off with the questions. Okay. So yeah, see you.